Let's solve the problem on heat transfer through plane wall. Let's assume you have a plane wall made of brick. This is the wall and having thickness of 25 centimeter, and both sides of the wall are coated with the plaster. This is the plaster layer having thickness of 2 centimeter both sides. If the thermal conductivity of plaster is 0.67 watt per meter per Kelvin and the thermal conductivity of brick is 0.2 watt per meter per Kelvin and the cross section area A is 1 meter square. So if the inner wall temperature is 0 degree and outer wall temperature is 40 degree, so we need to calculate how much amount of heat is going to transfer in this case. So we know the equation for heat transfer or conduction heat transfer through plane wall is Q is equal to Ka delta T by X. But this equation is for wall having the single layer, but this wall having the multiple layer, 3 layers. So this is the case of the composite wall. So let's write the equation for the composite wall. T by x1 by k1 plus x2 by k2 plus x3 by k3. Here suppose x1 is equal to 2 centimeter, so this is 0.02 meter, x2 25 centimeter, this will be the 0.25 meter, and x3 again 2 centimeter, so this will become 0.02 meter. Similarly, thermal conductivity K1 is equal to 0.67 watt per meter per Kelvin, K2 0.2 and K3 again 0.67. This is watt per meter per Kelvin, watt per meter per Kelvin, watt per meter per Kelvin. So let's write. So let's add the value in this equation. So cross section area is 1, temperature gradient 40 minus 0, and x1 is 0.02, k1 0.67 plus x2 0.25 and thermal conductivity is 0.2, x3 again 0.02 and thermal conductivity 0.67. So we'll solve this one. We'll get 30.5 watt. This is the value of Q. This much amount of heat will transfer if the inside and outside temperatures are 0 and 40 degrees centigrade. We can also calculate the interfacial temperature. Let's assume interfacial temperature value is T1 and this interface temperature is T2. For this we need to write the equation, separate equation for each section. So let's write the equation for first one. So we can write Q is equal to Ka delta T by X. We know the value of Q now. This is 30.5 is equal to K. K is 0.67, cross section area is 1 and temperature gradient is T1 minus 0. thickness is 0.02. If we'll solve this one, get the value of T1 is around 0.9 degrees centigrade. Similarly, we can get the value of T2 by writing the equation for this particular section. So you'll write Q is equal to Ka delta T by X. So K is 0.67, area 1, delta T 40 minus T2 by X 0.02 is equal to Q. Q value is 30.5. So if we'll solve this one, you'll get the value of T2 is around 39 degree centigrade. I hope you'll understand how to calculate the value of Q and interfacial temperature in the case of composite wall. Thank you.